Change of base for logarithms. The change of base rule is what allows us to calculate the value of any logarithm on our calculator. Is essential when we're solving problems involving logs and or exponents or variables in the exponents. There's two ways to look at the change of base formula here. The first would be if you're given a log statement, log base b of a can be rewritten as log a divided by log b. This allows us to plug any log into our calculator, whether it has a base 10 or not. That's the advantage. If we have the exponential form a equals b to the x, you can rewrite this as a log. X equals log base b of a, which takes you right back to where we were over here. Or you can kind of just make that jump. All right, the way that I always refer students here or give them hints is the base goes on the bottom. All right, so I try to use that letter association, base and bottom. Okay, so the log of a divided by the log of the base will give you the answer. Let's take a look at a couple examples. So first, some examples that you can do, probably even without a calculator, but it would be nice to have a calculator available. Here we have the log of 8 divided by the log of 2. So you type that in your calculator, you get an answer. 3. Okay. Next we have the log of 15 divided by the log of 3. And again, we're just calculating that, so you're typing it in, log of 15. In the calculator, make sure you close the parenthesis, all right, because when you type in log on your calculator, it opens a parenthesis. So when you type 15, you got to close the parenthesis and then divide by log of 3. Again, opens the parenthesis, close it. All right, hit enter. You should get your answer 2.46. Last here we have the log of 4 divided by the log of 32. Again, you're using the calculator to do this. So log of 4 divided by log of 32. Don't forget to close your parentheses. And we end up here with getting 4/10. So 0.4. If we have an exponential equation, again, we have two options. We can convert it to a log first, log base 5 of 2, or you can skip right to log of 2 divided by log of 5, because you remember that the base 5 always goes in the bottom of the fraction. So log of 2 divided by log of 5 gives us 0.431. You can round to 2 or 3 decimal places, whatever's fine. Log of 14 divided by log of 2 here. And last here we would have the log of 1200 divided by the log of 1.35. Go ahead and calculate those two and check back to see what you... So I end up getting 3.81 and 23.63 for those two. Let's see how it looks in an example problem. Given an account that accrues 5% interest annually, how long will it take for a $2,500 deposit to double, assuming we have no other deposits or withdrawals? First step here would be to write the equation. So identifying the pieces to the puzzle here is important. We need to be able to identify this as an initial value. We need to identify this, okay, as our percent increase. That's not the multiplier. You got to find the multiplier. So remember, for percent increase, it's 1 plus the percent over 100. I'm going easy on you here because there's no compounded. Okay, so we're going to have y equals 2,500 times 1.05 to the x power. Now, the problem is inadvertently giving us more information. It's actually telling us what the future value is, because it tells us or asks us the deposit to double. So we actually know what y is as well. If we didn't know that, we wouldn't be able to do this problem. So 5,000, 2,500, okay, 1.05 to the x power. So we're solving this. Remember, we can't multiply these two together because the 1.05 has the x. So we're going to divide by 2,500. A lot of people say subtract, but there's no addition here. So I'm not sure why you'd want to subtract. 5,000 divided by 2,500 is 2, equals 1.05 to the x. And here we are at a place where we need change of base. right? This is sort of the big idea. This is the part that you got to come out of this chapter with. The log of 2 divided by the log of 1.05 is how we arrive at our answer here. And there's no other way around that. Okay, there's not one you can do in your head or something like that. So when I type that in, I'm going to get 14.2 years. Now word problems, 14.2 years, it might not be a bad idea to change that to, 14 years and 2 months. Okay, but, I'll take 14.2. It's not 2 months, though, because of the 0.2. You remember that? Because there's 12 months in a year, not 10. So, and that's it.